There is a perfect visual formula for a slice of pizza. It's that slow, heavy stretch of melted cheese, the steam rising off a blistering crust, and a faint glisten of oil. But in 2009, customers told Domino's that their version of this experience was completely broken. Focus groups delivered brutal feedback. The crust tasted like cardboard, and the sauce was barely better than ketchup. This was a harsh reality check for a company that had defined modern pizza logistics, dating all the way back to that creation of the corrugated delivery box in 1965. Instead of making excuses, executives threw their entire recipe away. They went on national television, admitted their core product was failing, and promised to start completely from scratch. This global map highlights 5,000 store nodes connected by rapid supply lines, pushing out a pizza every 29 seconds. At this scale, even slight variations in flour moisture or sauce temperature create a totally different product for the consumer. The 2009 recipe failed because the existing manual supply chain couldn't maintain the tighter tolerances required for better ingredients. To fix the flavor, they had to replace human guesswork with a fully automated, mathematically precise manufacturing infrastructure. The physical architecture of a modern Domino slice begins inside one of their 16 Tier 1 distribution centers across the United States. Traditional bakeries rely on time and slow fermentation to build a dough's gluten structure. Domino's replaces that weight with physics, using a method called mechanical dough development. Inside massive steel vats, mechanical mixing blades churn through 800-pound batches of dough at 280 rotations per minute, forcing the gluten to develop rapidly. Once mixed, the dough is instantly portioned and sent into chillers kept at exactly 39 degrees Fahrenheit for 1 hour. This specific thermal window slows fermentation without stopping the rising process entirely. By applying exact mechanical force and strict temperature control, they guarantee that a dough ball baked in New York performs exactly like one baked in California. The unpredictability of traditional artisanal baking is completely eliminated. While the dough chills, the other core components are engineered at specialized Tier 2 suppliers. Raw tomato paste arrives in massive 1,500-pound industrial crates to be broken down. The new sauce recipe requires integrating a heavy herb blend, but heating it too much ruins the fresh tomato flavor. The margin of error is tiny. They blend the sauce at exactly 180 degrees Fahrenheit, activating the spice compounds while preserving the brightness. Over at the dairy suppliers, raw milk arrives by the tanker load and is pumped into 5,000-gallon holding tanks. Technicians introduce rennet, an enzyme that converts natural milk sugars into lactic acid. Within 40 minutes, thousands of gallons of liquid milk transform into dense, gel-like curds. Those curds move into industrial cooker stretchers, heated to 136 degrees. The machines continuously pull and knead the thick mass into a single, elastic mozzarella block. These hyper-specific chemical and temperature controls are the direct engineering solutions to the 2009 complaints. They replace the ketchup and plastic textures with reliable, high-quality ingredients processed at scale. All of these engineered ingredients finally converge at the Tier 0 store level. This is where the final assembly happens. Master pizza makers use a specific 6-finger stretch technique. They work the room temperature dough in circular motions to reach optimal elasticity without tearing the crust. Workers then use a patented tool called a spoodle, a flat-bottom ladle, to spread the sauce perfectly evenly across the dough in 3 rapid concentric circular motions. The final baking parameters are unyielding. The assembled pizza enters a conveyor oven locked at exactly 465 degrees for precisely 7 minutes. The store level operates entirely as a choreographed assembly line. By enforcing patented tools and rigid timing, they eliminate the variables of human error. But industrial precision in the kitchen is useless if the product degrades on the way to your house. Transport has always been the inherent flaw in fast food. To fix this, materials engineers spent years developing the heatwave bag. This cross-section schematic shows how the bag's layers reflect heat back toward the pizza while allowing moisture particles to escape out the top, keeping the crust crispy. They are even deploying automated EV delivery fleets to expand this strict environmental control. The journey to the customer's doorstep is now as regulated as the oven. This overhaul transformed their business model. Today, 62% of revenue comes from selling proprietary ingredients back to franchisees, supporting a $17 billion valuation. Every growth milestone validates tearing down the old recipe. Controlling manufacturing turned a failing product into a global commodity. Domino's built their success on absolute engineered consistency born from industrial logic. The pizza is simply a physical output.